In this video, we're going to look at adding and subtracting polynomials. A monomial is a number, a variable, or the product of a number and a variable with whole number exponents. If you look at all the examples, they all have one term. So monomial meaning one. We got an example is 10, 3x, half a times b squared, and negative 1.8 times m to the fifth. Those all have one term, so they're monomials. Looking at the next definition, we got polynomial. That is a monomial or the sum of monomials. And if you look at the examples here, we got 3x to the third plus x squared minus 5x plus 9. That's got many terms. Polynomials, many terms. And then the other example, we got 2x squared minus 10 and 3. 3 is a monomial, but a monomial is a polynomial. Looking at the next one here, binomial, that's the sum of two monomials, so we're going to have two terms. Looking at the examples, we got 3x plus 4. That's got two terms separated by the addition sign. The next one, x squared minus 4x, two terms separated by a subtraction sign. Next example, x to the third plus 5, two terms separated by an addition sign. And then the last example, 2x to the third plus x, two terms separated by the addition sign. A trinomial is the sum of three monomials. So look at these two examples here. They each have three terms separated by an addition or subtraction sign. We've got 2x squared minus 2x plus 1. That's got three terms. And then we have x to the third plus 2x minus 10. That's got three terms. Why we call it a trinomial. Alright, here we have an example of we're given a polynomial. We're asked to rewrite it and then identify the leading coefficient, the degree of the polynomial, and the constant term. Well, when we write polynomials, they should decrease with the value of their exponent from left to right. So look at what has the largest exponent. This one has the largest exponent, so we're going to write that one first. What has the next largest exponent? That would be plus 2x squared. The next largest exponent minus 5x, and then the lowest exponent plus 8. So now this polynomial is rewritten so that the exponents decrease from left to right. To identify the leading coefficient, we look at the largest exponent and the number that's in front of it. So here we've got a 4. This is going to be our leading coefficient. And next, it asks us to identify the degree of the polynomial. If you look at these individually, this degree is 3. This degree is 2. This degree is 1. This degree is 0. So we just got to look at all those degrees, which one's the largest. So the degree here, the greatest degree is 3. The constant term is the term that does not have a variable. So here's going to be our constant term. Our constant term is going to be 8. Here we have four expressions and asked to decide whether or not they're a polynomial. Looking first at the number 9, well, yes, that is going to be a polynomial. And in fact, we call this a 0-degree monomial. It has one term and there's no variable or exponent, so that's what we could say about that. Looking at this next one, 2x squared plus x minus 5, yes, that is a polynomial, and we say this is a second-degree trinomial. So second degree, looking at the exponent, and trinomial because there are 1, 2, 3 terms. Looking at 6n to the fourth minus 8 to the n, this is no, it's not a polynomial because we have a variable exponent. Looking at this one down here, n to the negative 2 minus 3, this is no because we have a negative exponent. Here we want to find the sum of two polynomials. Currently is a horizontal arrangement. I want to change it so that it's vertical. So I'm just going to rewrite it. We've got 2x to the third minus 5x squared plus x. That's the first polynomial. The second polynomial, I'm going to write it so that the exponents match up on top of each other. It doesn't have an x to the third, so I'm going to leave that part blank and put here 2x squared because they both have x squareds. There's an x to the third. We don't have any x's, and then we have a minus 1. So this part here is blank because there's no x term there. So if we look at this, now we're just going to add, it's kind of like combining like terms. How many x to the thirds do we have? We have 2x to the third plus 1x to the third, which gives us 3x to the third. How many x to the seconds do we have? Well, there's negative 5x to the second plus 2x to the second. When we put those together, we get negative 3x to the squared, x squared. Here we've got x plus nothing. Well, that gives us just x and negative 1. And that's what we get after we add those together. Alright, now we want to find the difference. We're taking one polynomial and subtracting it from another. So again, I'm going to change it from a horizontal arrangement to a vertical. So I've got 4x squared minus 3x plus 5, and I want to subtract all of this polynomial, 3x squared minus x minus 8. I'm going to rewrite it again here because if we're subtracting the whole second polynomial, I'm just going to rewrite it so that it's easier to deal with. This would become negative 3x squared. This becomes positive x. This becomes positive 8. So now I'm going to add those together. We got 4x squared minus 3x squared. We get 1x squared. If we take negative 3x and we add x, we get negative 2x. And if we take 5 and 8 together, we get 13. That's as simple as we can make it. None of those are like terms. That's what we get when we find the difference of those two polynomials.